In this video, we will show hybrid cloud routing for enterprises with Arrcus MCN. In this demo, we will show seamless hybrid cloud connectivity over multiple transports while utilizing cloud-native services. The setup is a hub-spoke configuration with an on-prem data center as the hub and spokes in AWS and a remote site. Connectivity between the three sites is over the internet. We will utilize the security groups and IAM policies configured in AWS. Cloud-scale NAT with overlapping IPs is also configured. The Arc-Edge instance will be deployed using Terraform and configured using REST API. Let's start the demo. Here we will show how to create and launch an Arc-Edge hub on-premise. In this example, we are using KVM Virtual Manager to create and launch the Arc-Edge hub as a new VM. Now let's configure the Arc-Edge hub that we just created and launched. We will log into the VM and go into the Arrcus CLI. Let's start by configuring the hostname and DNS server. Next, we will configure the MA1 interface with an IP address and subnet mask. Next, we will show the Arc-Edge spoke instance at the remote on-prem site. It has been deployed using Overt. We will log into the VM and go into the Arrcus CLI. Let's take a look at the running configuration to show that it has been configured similarly to the Arc-Edge hub we configured previously. The hostname and DNS server are configured. The MA1 interface has been configured with an IP address and subnet mask. The swap1 interface has been configured as it is a default next hop for all workloads residing in the on-prem remote site. A static default route is configured to point to the tunnel interface swap2. The username and password to connect to the Arc-Edge hub instance is also configured. We can verify there is connectivity established between the Arc-Edge spoke and Arc-Edge hub by pinging the Arc-Edge hub Docker interface. We can see the IP address that was auto-assigned to the swap2 interface. We can also see that all traffic from the spoke is now routed through the Arc-Edge hub to the internet. In this segment, we will deploy an Arc-Edge spoke in AWS and configure the Arc-Edge spoke to connect to the on-premise Arc-Edge hub. The AWS deployment of Arc-Edge is done using Terraform by providing the AWS details. The AWS access key, the AWS secret key, the AWS key path and name, the region and instance type, the VPC ID, the public subnet ID, the private subnet ID, enabling the private subnet to define this instance as a spoke. Now let's deploy the Arc-Edge spoke instance in AWS. You can see the Arc-Edge instance is now in AWS, and let's copy the IP address. Let's SSH into the instance and log into the Arrcus CLI. We can look into the configuration to see it is similar to the Arc-Edge spoke instance at the remote site we did in the previous step. Swap1 interface is a default next hop for all workloads residing in the AWS private subnet. Swap2 interface is a tunnel interface. A static default route is configured to point to the tunnel interface swap2. The username and password to connect to the Arc-Edge hub instance is also configured. Let's verify the connectivity by pinging the Arc-Edge hub. We can see the IP address that was auto-assigned to the swap2 interface. We can also see that all traffic from the spoke is now routed through the Arc-Edge hub to the internet. With Arc-Edge running Arrcus underneath, you are able to leverage the full routing capabilities of Arrcus. This allows users to utilize dynamic routing protocols such as BGP, OSPF, and ISIS to be configured on top of the overlay network, as well as security features such as ACLs that can be applied at a workload level. In this segment, we will show that traffic from the on-premise workloads at the remote site will go over the overlay network through the Arc-Edge spoke instances and the Arc-Edge hub instance. On the left side of the screen are the Ubuntu workloads in AWS. On the right side of the screen are the Ubuntu workloads in the on-prem remote site. You can see that the workloads in AWS and the remote site have the same overlapping IP addresses. We can also show that we have IP connectivity from the AWS workload to both workloads in the on-prem remote site. Let's log into the AWS workload. Let's ping the first workload. Now let's ping the second workload. The entire deployment in AWS can also be deployed using Arc Orchestrator's GUI. In summary, use Arrcus MCN to build flexible routing-centric hybrid cloud networks, orchestrate and automate your network at scale, and deploy multi-cloud seamlessly across on-prem, edge, and cloud providers of your choice.